welcome to the iXblue Defense Systems UATR tool Capstone project. I'd like to introduce our technical directors, Daniel Nugent, Patrick Moran, and Patrick Leifring. I'm going to also introduce our team, myself, Michael McHugh, a computer engineer, and my partner, Brent Moynihan, also a computer engineer. iXblue is a company located in Lincoln, Rhode Island, and originating from Saint-Germain, France. It's a French technology company, and it specializes in internal navigation systems, otherwise known as INSs. And it is a global leader in navigation and positioning technology. What is an INS? An INS, as I said before, is an inertial navigation system, and it's used on multiple different boats, submarines, and other various aquatic machinery. The INS system that we're primarily using in this project is the FINS Compact series, which is detailed in front of you. iXblue had a great project motivation for this year, which is that inertial navigation is a growing field. High performance equipment must be frequently tested, and the current test tool is non-automated, so it is very difficult to test and use the time efficiently. And the automation decreases testing time, like I just said. Now, the anticipated best outcome of this project was a fully automated UATR tool, a user guide for the tool, and software design documents. Was it achieved? Not necessarily. However, we made great progress in finishing this project this year. Some of our accomplishments were a GUI to send commands, creation of log data from the commands sent to the INS unit, digestion of the log data, the commands and the data parsed, condition tests and biases calculated, and a project report documentation. Now, like I said earlier, the accomplishments were data parser, graphical user interface, GUI, sending INS commands directly through an open data stream, creation of log data, the UATR block diagram that helped guide us throughout this entire project in the report document. The economic impact for iXblue is that it decreases testing time, eliminates shipping to the facility, increases company efficiency, and it is applicable to all INS devices. Now, this is very important for the company. This is the block diagram, as I stated before. It essentially just shows what needed to be automated, what needed to be user inputted, and what the INS does itself. Now, the data parser was the first of the accomplishments made by myself. It reads in log data from a previously created log file, which the INS will be outputting when connected to it. It uses Python code to open the repeater data flow from the INS. It locates line by line data, and it parses it out individually into pandas data frames. And then it splits the string into pieces and converts them to floats, because we have to work with integers and floats when dealing with the numbers to calculate all of the condition tests and biases. Now, how this is done is the log data here is stored line by line as different stuff. So this is an example of latitude, longitude, and altitude with a checksum. So the first bit of data is your degrees in latitude, and the second is your longitude, and the third being your altitude attached with a checksum. So the data parser needed to be able to grab each of these indexes and put them into their own Python pandas data frames. And as you can see here on the screen, this is a latitude v longitude graph created from the test file. Now, the data parser also displays data in the report at the end of the program, and it uses pandas data frames to do so, and they're plotted on graphs like I showed you before using the library matplotlib. And they're saved as PNG images, and they're exported directly into the PDF file, so the user won't have to search their computer for it. It's all saved in the project folder when they run this code. The condition test, as I mentioned before, only work when the ZUPT mode has been turned off, which is a command you have to send to the INS unit. So once the INS receives this command, the test begins. However, the overall UATR test can take a lot of time. The only data that we want to test is when this ZUPT mode is turned off. So essentially, as you can see on the right, you have heading, roll, and pitch versus time. These are all stored in those pandas data frames that I mentioned before, and depending on if the numbers are negative or positive, we get these working data bounds, which are the red lines you see there. And essentially, if any data point is higher or lower than those red bounds, the INS being tested is faulty, and it should end the test. So as you can see, the unit that we tested here passes the test because none of the lines pass none of the graph passes the data bound lines. Next, commands were sent to the unit, and they show up in the data flow as lines like I showed you before, like how we parsed out the latitude, longitude, heading, roll, and pitch. So we had to develop a way to find and pick these specific commands that are the INS type, the INS serial number, the loader version, and the FW version. And they had to be parsed and put into the report document so that when someone's running so many different units to test, they'll be able to tell which one's which attached to the document. So this was very important. And this will be also printed out for the in process and for old data files when you're running the test on the unit. The test report document is the last accomplishment that I personally contributed to, which is essentially a PDF document generated from the Python code that includes, like I said before, serial number, type, loader version, FW version, as well as heading max and min, roll max and min, pitch max and min, all of the fog and Excel biases in the X, Y, and Z directions, as well as positional drift that for 30 seconds, 1 minute, 1 hour, and 8 hours, which is the length of the test for this specific INS device. So this will all be printed in a document from the Python code. The user will be prompted to just pick what test data they want to run, and then after a minute or so, after it runs through hundreds of thousands of lines of data, it'll print out this report saying whether or not it passes, fails, with the appropriate graphs attached. Now I'm going to pass it off to my partner, Brent, who's going to explain some more of the technical accomplishments design.
Hi, my name is Brent Moynihan, and I'm the second designer for Team iXblue. My first major accomplishment for this project was creating the flowchart diagram you see before you. This flowchart diagram goes over every portion of the test that need to be implemented either by the user or the team designers themselves. So on the top right, we see what the user has to do manually before the test starts that we can't automate. On the top left, we see what the INS does automatically that we already don't have to automate. And on the bottom, we see what the program does that the team designers had to implement. So it breaks down every portion of the test modularly so we can easily implement them. And we just went over every portion and tried to implement each one as best as we could. As we saw before, this is a condensed version of the flowchart diagram you just saw. This goes over the absolute most important portions of the test that we need to implement to make sure we can make it fully automated. Another major accomplishment I had for this project was creating the User Interface Gui that is shown to the users themselves. It's the front end of the project, and it's what the user itself interacts with. So this is what the GUI looks like. As you can see, on the top is the live portion of the test. The user would have to implement their IP address, latitude, longitude, and altitude, and press the start button. This would start the test, and all their information would go into different functions and set it to the proper value so we can actually do the test properly. In the middle is a replay function, where if you had a previous log file that you had and wanted to test it again, you could replay the file and it would output the biases and PDF values of that log file. On the bottom are indicator timers and lights that would show what portion of the test is actually going on. So at different times, these lights would light up either green or red to indicate what portion of the test you were on. And at the bottom, the light would turn green, done, to indicate to the user that the test is done and they're allowed to stop the test. Another major accomplishment I did for this project was figuring out how to send commands to the INS. This was a little difficult at first because we didn't know exactly how to do it or what signal to get back. But the INS comes with an advanced configuration guide which details out all the syntax and the correct portions of the commands we should send to the INS to change their functionality. So this is what we started on the bottom, and our initial goal was just sending commands to see if we could actually do it. And at the top, we use Hercules, a server client program, to test the program when we were at home to see if we could actually send commands to a server, which would be the INS in our case. And we were able to. The commands go through, and when we tested it on the actual INS, we would use the user interface that iXblue provided for us, that they already have going, that shows us the main specs of the INS and all the operations that are going on. So for the zup command on that we need to test, which if we turn the zup command on, it sets the 0 up position to 0, so it acts like it's not moving. That gets turned on, and we could see that on the right, the zup is enabled once we send the command. So we can confirm that the commands were being sent actually go through and create different functionalities within the INS. This is the crux of the whole project itself, is being able to send and receive commands and signals from the INS to make sure that the test is going properly and that the information we're getting back is correct and viable. We would like to acknowledge Daniel Nugent and Patrick Moran, our main TDs, and special thanks to Patrick Liefering for helping us out. We really cannot do it without these guys, and we're so happy to be able to be part of their team. They really taught us a lot, and I'm glad to be part of their team. Thank you so much.